Well, hello everybody. Welcome to Live Code Tuesdays. We're gonna get started here. I'd love to see in chat maybe if people can hear me. This is my first time doing the stream today. But yeah, welcome everybody. Go ahead and put in chat where you're joining from. I'm excited to learn about that. Today for the Live Code Tuesday, our Nginx stream was unfortunately canceled. We weren't able to do that this week. But fear not, we're still going to be plowing ahead today. And yeah, it's just going to be me on stream today. And I'm going to be going over some of the OpenTelemetry work we've been doing in Spin over the kind of past month or so. And we're also going to be talking about WASI Observe, this new upstream standard we're working on, which is really exciting. And I guess before I get too far, my name's Caleb Schoepp, as you can see on screen. I'm a software engineer at Fermyon. And yeah, I'm super excited to be here. Looks like we got good audio, which is great to hear. Again, I'll say this again. This is my first time, so I'm learning to live stream, doing it live, and excited to have people from Quebec and Karen from NYC. That's awesome. Okay, so I'll give you kind of a bit of a heads up what we're going to be doing today. We a couple streams ago already went over some OpenTelemetry stuff. I was here with Kenzie, and we talked about OpenTelemetry, what kind of a standard it was. The support for tracing we have in Spin, and kind of went over a demo for that. But we made a lot of progress since then. So we're going to go through that again. We're going to see what our tracing support looks like. We'll dig into the new metrics support we have, which is really exciting, and along with some logging support. And then we're going to close out with kind of like talking about the WASI Observe work I've been doing and what all that upstream stuff is and how that's all going. Throughout, I'm going to be asking questions. I'd love to understand more about, how Spin developers are using this kind of observability tooling and the things people are looking for. So watch out for questions like that. But let's just dive in. Let's start going. So I'll share my screen here. Perfect. I think that's a reasonable view there. And let's just bring up my terminal here. So actually, before we do that, I'd love to just talk a little bit about OpenTelemetry. So we talked about this on a previous stream, but for anybody who doesn't know, OpenTelemetry is like an open source standard for observability in your applications. Oh, okay. Apparently, I've got something going on with the weird loop every 30 seconds. Well, I'll keep going here, but maybe add another comment if the stream isn't working or something like that. Just in case, I'll pull up my Slack here so that my team can help me out if necessary. Okay, so OpenTelemetry is an observability standard, and the important thing I want to point out is that there's 3 different kinds of like signals in OpenTelemetry, and so a signal is really just like a type of data that observability can emit. So there's traces, and traces look a little bit like this. This is a trace of an application, and it shows you kind of like the functionality of your app. So a span represents like a duration of work, and you can attach metadata to spans, and then they're nested to show kind of how the app runs. So that's traces. And then there's metrics, which are like request counts or things like that, and show you kind of totals and how that's all working. And then there's logs, which is just kind of the logs you're already familiar with from the application, and you're able to push those through to other systems. So that's kind of the core of OpenTelemetry, these different signals, and then different applications can support different parts of these signals. And so as we're improving the observability support in Spin, we're starting to support more and more of these signals. Great. So that's a really quick primer on OpenTelemetry. If you're super new to that, highly recommend like checking out their docs. Their docs are really good. Or I also would recommend going back and maybe watching our previous live stream that I was on with Kenzie, where we talk a bit more about OpenTelemetry in depth. Just before I go too far, I just want to make sure the stream's still going good. Looks like Mohammed was having some trouble, so throw something in the chat if people are struggling. And welcome from Rome, Italy. That's awesome. Great to have you here, Arthur. Cool. Okay. So one of the first things I want to show off is that we now have the ability to spin up an observability stack really easily. So when you're running, these kind of observability tools, you need to have a bunch of tools running in the background that make it super easy to kind of port all this data around. And so if I just check out the right branch here, we're going to be doing some live coding together. So, get ready to be in the terminal together here. And I check out, let's do which branch? Let's do this branch. We now in the Spin directory, if you have Spin cloned locally, have an observability stack directory. And really all this is just like a Docker compose file that automatically will spin up all the dependencies you need for running it locally. So that's going to be spinning up things like the OpenTelemetry collector, Jaeger, Tempo, Prometheus. I'll talk more later about what all these different services do, but it's this kind of like one-stop shop for spinning these up. So I already have them up, so I'll just take them down quickly, and then it'll take a second to take them off the network, and then I'll show you how you can spin those dependencies up. But while we're waiting for that to run, really the kind of key linchpin dependency here is the OTeL collector, this one right here. Also, go ahead and put something in the chat if the font's too small. I think I've got it big enough here for folks, but I want to make sure people can read what I'm doing here. But as I was saying, the OTeL collector is kind of the linchpin here. And the OTeL collector is responsible for taking in all these signals, the logs, the traces, the metrics from your application. It goes into the collector, and then the collector is responsible for forwarding that data on to all these different backend data services like Prometheus or Loki or Jaeger, etc. So if you want to set up this kind of observability stack for yourself, you can come in here and you can run Docker compose up, and we'll do it as a daemon in the background. And now we've got all these services running, which is perfect. Um, Great. So that's just one kind of convenience thing I wanted to point it out. Before we were just advising people to directly run Jaeger, but now there's a lot more tools involved to support all these different signals, and so this kind of really simplifies that process. Awesome. So next thing I wanted to show was just kind of tracing support. Nothing super new, exciting here. We've already had support for tracing for a while now, but I always think it's kind of worth showing again. So we'll just go to the sentiment analysis app. And this is a sentiment analysis app from the Spin Up Hub. This was an application we built a while ago from back when we were releasing the AI SDK, and it's just kind of a fun little demo app for that. So we'll run that app locally here. And throughout, you'll notice I'm going to be running Spin using Spin Release. Spin Release is just an alias I have locally for a locally built version of Spin, because I'm going to be using a bunch of different prototypes of Spin I have locally here on my machine. And so if I just pull this up again, KV Explorer, perfect. Okay, so this is running the app Spin Release up, and we're passing it a couple environment variables to configure it. So the first and most important environment variable we're passing here is the OTeL exporter OTLP endpoint, which is just a really verbose way of saying, hey, here's where the OTeL collector is running. This is where I want you to pipe the observability OpenTelemetry data to. And then we've got these spin variables for the KV Explorer user and password, which can just kind of largely be ignored for this demo. So we'll run this application here. And then if we go to this, we can pull up the application here and we can, do a test. So we'll do QWERTY. I'm curious what QWERTY will analyze as. Now, we can see some logs here. We're performing sentiment analysis on QWERTY, and we can see that it wasn't found in the cache, and we're running inference. Since I'm running this on a local model, it's going to be really slow. My MacBook's not that fast, so we can expect this to take about like 30 seconds. But while we're waiting, I'm going to ask a question of the crowd here. I'd love for people to just kind of share, have you worked with OpenTelemetry before? Do you know what OpenTelemetry is? Or is this your first time hearing about OpenTelemetry? Love to hear about that from people, kind of get a gauge of familiarity with OpenTelemetry. There we go. Okay, solutions come back. Surprise, surprise, QWERTY is neutral sentiment. Okay, so that's great. The app's run. Now, what we'd love to do is we'd love to go in and be able to kind of understand the trace of how that ran. So we'll come in here to Jaeger. And if you remember from earlier, Jaeger was one of the kind of dependencies that we spun up in that observability stack. And Jaeger is basically a trace backend. So the OpenTelemetry collector is able to push spans from the collector to Jaeger, and then we're able to view them in Jaeger. So if I find traces here, we'll see there was a post made to our API endpoint, and that's from the UI. Also, notably, there was some GET requests made. These were the GET requests against the UI, and so it's making a GET request against your application and then executing the UI WebAssembly component. But the more interesting one here is this one. So we're making a post to our API endpoint, and we're executing the sentiment analysis WebAssembly component. And then we can see a couple things going on here. So if we zoom in on the start here, we can see that we're getting a key value store, and then we're getting a value from there. And we're getting the key QWERTY. So we're saying, hey, do we already have a cached response for QWERTY? The answer is no, there's nothing cached yet. So we're running this local inference, and we can see, this takes 48 seconds. And then if we zoom in at the end here, we see right at the end there, 785 microseconds, we set that value in the cache. Now, if I were to go back here and run this again, QWERTY, we get an immediate response because it's cached. And then we would expect in here to see that there's another post against the API, but this one's only taking 13 milliseconds because it's coming in, getting the key value store, and then getting that value, which is already cached. Great. So, that's kind of a demo of the trace support we have. We've come a long way in the kind of past month. We had just preliminary tracing support, and we're only supporting a few trigger types and a few host component types. But now the vast majority of Spin is traced, and I think it's kind of really handy to be able to understand what functionality you're using in your app and seeing where the bottlenecks are. Towards the end of this stream, we're going to be getting more into things like WASI Observe, which is actually like doing tracing from within the guest, as opposed to just the host emitting tracing, which we'll just leave on the side for now. And I'll kind of break down that terminology a bit more in the future. Perfect. Okay, so that's tracing. I also just want to briefly demo. We also have support for tempo as a backend. So not only is the OpenTelemetry collector sending traces to the Jaeger backend, but it's also sending traces to the tempo backend. And so if I do a search for traces here in tempo, which I'm admittedly not very familiar with, but we can probably choose this way. Yeah, there we go. So we're searching for the service name spin with spans with the name post to API. We run the query. Great. We can see these two traces, and then we can kind of expand them, click into them, and get the same kind of insight that you're familiar with in Jaeger, just in a bit of a different format if you're used to Grafana. Cool. Okay, so that is tracing support, initial host tracing support. And next thing I kind of want to demo for everybody is we've landed metrics support in Spin, which is super exciting. And so we've already executed this application a few times, and metrics support is already on the latest of Spin. And so let's go ahead and see how that's working. And so first thing, we can just demonstrate that. Let me show you the OTeL collector file. There we go. So this is the, whoops, let's do it with bat. So this is the OTeL collector config, and this is showing, we're receiving data from our apps at these endpoints, and then we're able to export them out. And so for traces, they're being sent out to Jaeger, and they're being sent out to Tempo. But for metrics, they can be sent out to Prometheus, which is like a metrics backend. So if we scroll down here, we can see that metrics are being sent out to the Prometheus backend, and then Grafana is able to display that for us. Awesome. And I see we've got a comment here from Mohammed. So still exploring. We have not managed to have a complete view of the web app front end up to the LLM model. Goal is to have a complete history of a query. It is capture points of attention. Awesome. And I'm assuming that's in reference to kind of experience with OTeL. So that's great to hear that you're still exploring. I know it's kind of super nascent in the community right now, but it's really great to see the adoption kind of rising with OpenTelemetry. And it's exciting to be able to support that in Spin. So as I was saying, we've got these metrics, and they're streaming through to the Prometheus data storage backend. And then if we go here, we can then go, we're in Grafana, and we can say, let's use Prometheus as a backend. I'd love to see spin request count total. And let's run that query. I don't know how to get rid of this split pane. Great. So here we go. We can see we've got some metrics. And so spin request count is just, how many app requests have come into your Spin app. And so we've got two lines here. The first one is requests against the app ID sentiment analysis. And this is for the UI component. And this is for the sentiment analysis, like API component. And so we can see, our requests for that over time. And if I were to do like QWERTY, we'd probably be able to demonstrate that there's, once this propagates through, a jump up in requests against the API. But that probably will take a second to propagate through. Now, our support for metrics in Spin is still really early. We're just really tracking request counts against, applications using the HTTP trigger or the Redis trigger. But we'd love to continue to support metrics more thoroughly throughout Spin. And so this is kind of a point where we're really looking towards the community to understand the metrics that y'all are looking for in your apps, whether that's error counts or yeah, I don't know. I'm curious to hear from everyone here and the community what people are looking for. So go ahead and comment in the chat if you've got ideas for kind of metrics you're looking for in Spin. Another comment here from Mohammed in reference to the earlier comment and possibly profiling to control latencies. I love that comment. One of the things I love the most about looking at traces is it gives you such a good idea of where the bottleneck in your application is. So, for example, here it's pretty clear that basically all of the time, this is taking so long is because this local inference is so slow. And there's even different views, like you can do flame graphs, which kind of give you this nice idea of what's really expensive. And so, yeah, I think the ability to kind of monitor performance and understanding it more directly with these traces is really handy. Great. So, pretty short with the metrics. But yeah, keep the comments coming in. I'd love to hear what kind of metrics people are interested in having. But it's, the support's there in Spin. So open up issues or drop comments in here, and it's really easy for us to support new metrics in Spin now, which is super exciting. Okay, so I'm gonna keep plugging along here. The next kind of signal I want to talk about and show everyone here is logging. And so the logging signal is kind of like an interesting one in OpenTelemetry because it's basically just acknowledging that a lot of the software engineering world like runs on like logs that aren't necessarily like timestamped into spans. And so they're just trying to make it easy to take the kind of like existing log infrastructure and tie that into this open telemetry ecosystem. So we haven't yet landed any support for logging in Spin. But if I go here and then we go just back out to Spin, I'm just in the local Spin directory here. And then if I go to, I want to go to a special branch. So logging signal basic libraries. Perfect. Okay, so this is a branch I have locally. I'm going to build this different version of Spin, and that will take a hot second. So we'll keep going while that builds. But so this is a prototype of Spin that supports this open telemetry logging signal. And the way it does that actually is it's going to be taking any logs that you're emitting from within your Spin app. So, an example of a log you're emitting from within your Spin app would be here, like in this sentiment analysis app, when I do a console.log, this is a log coming out of my Spin app. And, normally you're just going to see that coming out here in your terminal. These are the logs. But with this special version of Spin I have locally, we're going to be supporting piping that log through and sending this through the OpenTelemetry collector. And where that's actually going to get sent through the OpenTelemetry collector is it's going to be sent off to a log backend by Grafana called Loki. And so Loki really just is basically a logs backend that allows you to kind of create ad hoc queries against these logs based off different attributes and things like that. Okay. So still building here, we'll take this opportunity for me to learn more about Grafana and figure out how to, there we go, close split plane. Awesome. Learning on the job. Great. So we're done building Spin here. And again, just a reminder, I'm using Spin release, which is just aliased to this locally built version of Spin, my prototype of Spin here. And we're going to rerun this application. Great. So we're still passing the exporter OTLP endpoint. And we're spinning up here. Perfect. The application's up and running. Now, if I go ahead and come here, and let's say I just make another request to the cached value, we we'll see some logs coming through down here, performing sentiment analysis on QWERTY, found sentence in KV store, returning cache sentiment. Perfect. Now, if I go to Loki and we do, nope, we want to do kickstart your query. No, how do we do this? As you can tell, I'm still very new to these backend tools. Label browser. Is that what I want? So it's going to say no data because I need to pass some sort of. There we go. That's what I'm looking for. So this is saying like look for any logs with the attribute level that has the value info. Um, and we'll see no found. Oh, I know why we see no found. Let's try resource. Nope. Okay. There we go. Let's try job. Perfect. Okay. So great. So I got to be honest, I'm pretty new to Loki, so I can't actually explain the query here. I believe this is searching for attribute job equals spin. Although I'm a bit confused why there's no job equals spin attribute down here. So maybe someone can teach me about that in the chat. But the point stands that we've run our sentiment analysis app with our prototype version of Spin here, and we've passed this exporter, and it's piping the logs through the exporter into this Loki backend, and then we're able to query it with Grafana, and we can see these logs being emitted. And so the body of the log, found sentence in KV store, returning cache. And then this resources information is like basically OpenTelemetry. It's an OpenTelemetry resource, which is another way of saying what is the application, the source that is producing this OpenTelemetry signal. And so we can see our logs here. So, this is kind of handy, and I just want to demonstrate a few more logs coming through, and maybe I'll just do a different value that's already cached. We'll do that, and that can grind away in the background. This is basically just demonstrating, I think, in a nice way, how you could just out of the box be able to use the logging that you have in your Spin app and be able to get these logs here and kind of aggregate them. And then the other nice thing about this is you could point that logging at Datadog or other kind of backends that maybe support the things you're trying to achieve or the things you're trying to do. Awesome. I see we've got a comment here. Provide cybersecurity requirement in terms of the logs that must be captured and the important signals to raise alerts in appropriate manner. Yeah, that's a big topic. One of the things that comes to mind to that for me is that if I go to hack Ollie stack, in the OTeL collector config, I think it's in here. There's processors, which are basically like when you define a receiver for some logs and then you can send it through a processor and then you can send it to an exporter. The processor would let you perhaps kind of meet those like cybersecurity requirements where maybe you obfuscate certain pieces of user data or you filter out or sample only kind of the data that's relevant or secure to pipe through. So yeah, I think there's a lot of different ways you can kind of solve that problem in the ecosystem. But yeah, if you have more specific requirements around that, I'd love for you to open issues in Spin and kind of continue that conversation about how we can meet those needs. Great. So this is the demo of the logs. Let's see if my query is doing the thing. Yeah, perfect. So we ran a bunch more requests, and we can see the logs are coming through now. And yeah, I just think this is kind of like a really handy way to enable that. So still a little bit while before this is probably going to land in the main of Spin or be cut into a new release of Spin. But something to keep your eye out for. Now, this is great having just the logs of your application. But in addition to kind of just having the raw logs of your application, it'd also be really nice if there was a way for you to see where those logs are tied into the actual like timeline of your trace. You know, I don't just want to know like, okay, caching sentiment in KV store, but what I'd like really love to know is where in this trace was that like caching occurred. I mean, you can sort of like infer that like it happened by the set, um, but you could imagine in more complex applications where it's hard to like know where in the lifetime of that trace those things are going on. And so the best answer to this problem is tracing from within the guest, which I'm going to again paper over because we're going to get to that at the end of the stream here. Um, but like the second best thing we could imagine doing is having sort of this like compatibility layer. And so something's bugging out with that trace. So let me just reload it. Um, for example, you'll notice if I really zoom in here, um, you'll notice there's a log emitted on this span. And this is saying like processing requests for application sentiment analysis on URI. So this is actually an event, a tracing event being emitted from the spin host, the spin CLI itself. And these events are a concept in OpenTelemetry, which is basically like a log, but specifically attached to a span at a specific point in time. And so what would be really nice is if we had a way where the logs you're emitting from your application, right? These logs, what like I would love for that to be able to appear on my trace as these kind of like logging events as moments in time so you can understand those things more directly. And so that would like solve probably like 50 to 80% of the problem that these upstream WASI observe, in guest tracing things are trying to solve as kind of this like holdover solution. And so I actually have a prototype of what that looks like too, and we're trying to land that in Spin. So let me just check that version out. And actually, I think that should be showing up. Let's just see. Is that showing up? No. Okay. I think I have to go build it on a different version of Spin here. So if we go to OTeL logging, I think that's the one we want. And then if we build that, and again, yeah, we'll wait for that to build because that takes a second to build. But while we wait for that, I will try and see actually if I can find an older version of this that does this. Hmm. Nope. Okay, we're gonna have to build it new and do that. Okay, but while we're waiting, I'd love to hear more from people in the chat about what kind of logging solutions are people using. Are they using Datadog in the backend for their logs in their applications? Are y'all using things like Loki and these kind of like open source tools? It'd be great to hear more about what kind of tools people are using. And looking at the view count, looks like maybe we had a few more people joining us. So, hi, my name's Caleb. We're just going through kind of the new OpenTelemetry support and Spin. And then towards the end here, we're going to be chatting about WASI Observe, which is kind of the upstream standard on tracing in WebAssembly. I will say this is one of the most painful things about developing Spin. I love Rust. I really do love it, but I spend a lot of time staring at it compiling. Okay, perfect. So if I run the application here, and we run up, and if I go here and I reload the page and I run QWERTY analyze, I should expect to see. Yeah, perfect. Okay, I don't know what's happening before, but it's working now. So, we're talking about how it'd be lovely to see these logs as kind of like trace events directly in the span. And so now we've got them. And so here, for example, on this span, we've got some logs that are emitted. At this moment of time, 2 milliseconds in time, we see an app log, which is, post sentiment analysis. And then we see an app log, which is performing sentiment analysis on QWERTY, et cetera, all these kind of logs. And now, like, the really important thing is that they are directly like linked in to this trace as events. So you can actually just directly write your logs in your Spin app and pass it to a collector, and then it's automatically going to pipe through and your logs are going to be tied into your span, which I think is like really exciting because all of a sudden now it gets a lot easier to understand what's going on here in your app. I think it's worth noting. Software update. No thanks. I think it's worth noting that there is a way to shut this off, which I don't remember what it's called. So we're going to go into the code, and that's in here. Yeah, this is what it's called. So, just as an example, if you don't want this enabled, like you're like, I don't want my logs in my traces, I don't want that done, you can disable it with this app log to tracing event disabled. And if we were to come back here and run QWERTY, analyze, let me just get StreamYard up again, and we come back here, we'll see the latest post, and we're not going to see these events. I'm not quite sure why you wouldn't want that compatibility layer. I think it's pretty handy, but that option exists. And just to talk about the implementation for a second, I don't want to go too deep, but I think it's really cool. Basically, we're taking in these logs, and instead of just like directing them to standard out, and in addition to that, potentially a file, because Spin also logs to a file if you want, we're emitting that as like a tracing event within Spin itself, and then using this like cool compatibility layer that we built to map it over to these OTeL events. So if you're interested, I highly recommend checking out the PR. It's a pretty cool implementation. Awesome. Okay, so we've got some comments here. So we got Bunny saying, I consult and see a variety of monitoring, mostly native cloud, AWS, GCP, built-in monitoring, Datadog, Prometheus, and the like. Got it. Cool. Yeah, that's really good to know. Yeah, it makes sense that a lot of people use the kind of like AWS and GCP solutions. If you're baked into using their VMs or their hosting solutions, it's just kind of easy to use it that way. Awesome. And Otis, I haven't used any, but I'm interested in Loki. Yeah, I just discovered Loki like probably a week or two ago when I just started working on this implementation, and I was actually really impressed with its functionality. I will say, logging support is kind of like infamously new and like not super well supported within the OpenTelemetry ecosystem. And so I was kind of hesitant to start working on this, but I found it to be actually fairly well supported, and the collector sort of just works out of the box, and Loki works out of the box. So I don't think it quite deserves the like sort of reputation of not being fully supported that I've heard it to have. That is OpenTelemetry logging. Great. Okay, so that's logging. We've kind of gone over the three big signals here. We've talked about tracing, we've talked about metrics, we've talked about logging, we've talked about this sort of like logging compatibility layer so that you can get it into your traces. And this is all amazing. Like, in my opinion, this gets you like 80% of the way to where you want to be with observing your Spin application. You can understand how long it's taking. You can understand metrics, like how many requests are you getting. You can understand timing, and you can directly correlate things within your app to these traces to make debugging easier. But I'd say we're only like 80% of the way there, and getting the final like 20% of like observability in your application is really going to come down to being able to do observability, this kind of tracing work within your guest application itself. Excuse me. Now, I've been breezing over this for a while. I've kept alluding to guest tracing, been saying, we'll talk about that later. We'll talk about that later. I think it's time that we talk about that right now. But before we do, there's actually a really good question here that I want to answer. So, can it work with a Dockerized Spin app? The short answer is it should. It should. So you would run your app in a Docker application, and as long as you have an OpenTelemetry collector that is accessible from that Docker application, it should work. So whether you're using Docker Compose to run uh, your collector and the app, and then use like the networking within Docker Compose to connect the two together. So in that case, instead of passing like uh, localhost 4318, you'd probably do something along the lines of like um, whatever you called it in Docker Compose, but OTeL collector 4318. So that should work. And then actually, this is such a great question because maybe before I talk about WASI Observe for a second, I'd love to just highlight, support for this in other places. So another big thrust of work we've been working on is the making sure that all of this observability work is supported in SpinCube, which is our sort of open source project for making it really easy to run these serverless spin apps in Kubernetes. And there's a blocker for quite a while in getting all this observability working there for kind of unexciting reasons. But the exciting news is that we just got past that blocker, and so support for observability has landed in the containerd shim spin, which is like a project that SpinCube relies on. And so there's still a few things to work out around the edges of like how do we configure observability in SpinCube. We're actively working on that. In fact, I'm going to a Run WASI, open source meeting right after this to talk about it. But we're so close, and so I'm really excited to be able to support this observability. Running Spin locally, running Spin in a Dockerized setup, and Nomad and SpinCube, kind of all over the place. Great question, Otis. Really appreciate that. Anyways, as I was saying, we're 80% of the way there with observability, but we need to get this last 20%. We get the last 20% by getting in-guest tracing. What does that mean? Well, everything we've done so far is in the host, and the host is like Spin. The host is the thing that's like actually executing this Spin application, which you could call the guest. And so, these traces, this is emitted by Spin because Spin knows when a post request is made to your app, and Spin knows when you're executing your app, and Spin knows when you're using like the key value store that Spin provides to your app, or the LLM that Spin provides to your app. But you're not able to write directly in your code. So if I go, let's imagine you're like a Rust developer. What you would normally do is if you're writing a Rust application is you'd be like, okay, I'm writing my code. I like grab my OpenTelemetry library, get a tracer, make my span, do some work, and just do it directly within my application. As of today, you're not able to do this in a Spin application. Your Spin application can't use an OpenTelemetry library to emit spans that it arbitrarily chooses to emit. All you're allowed to get is these kind of spans, these host spans, I call them, or trigger tracing, which is Spin knowing, hey, you probably want to know when your app is requested. You probably want to know when you're using any of these dependencies. And so guest tracing is you being able to emit whatever metrics, whatever spans or logs or whatever you want from within your application. And so the reason I kind of talk about this, like this sort of let's go back to the example here where I had that working. This sort of compatibility layer of the logs getting into your traces, like this sort of gets you there because like you can choose to emit a log from your application that gets tied into the trace, but you'd really love to be able to emit your own specific trace and spans from within your application. So, that's the final 20%. And what are we doing to support that? Well, this is where the open source project, or I shouldn't describe it that way, the upstream standard, WASI Observe, comes in. And so I think it's worth kind of taking a step back and talking a little bit about what is WASI and then what is WASI Observe, just to give some context. And so WASI stands for the WebAssembly System Interface. And WASI is basically like, I'll put this in the chat for people if they're interested. WASI is basically like, I have a WebAssembly module. but I have some like resources on the system that I want to gain access to, like environment variables or like file systems or tracing and observability in our case, or key value or whatever, these kind of things. And it's how you bridge this gap from a WebAssembly component, which can only do like basic computation, to all these kind of system resources. And so, there's a whole ton of different interfaces and standards within WebAssembly and excuse me, WASI. So, there's WASI IL for input output, and random for random numbers, and HTTP for handling inbound and outbound HTTP requests. And so, WASI Observe is the WebAssembly community getting together and saying, "Hey, we want to support WebAssembly components being able to emit these spans." So that's what WASI Observe is. Um, I think it's important to note WASI Observe is like super early days. We're still like defining things and playing around with prototypes and kind of messing around. So, still very early, but I think it's an amazing time to get involved in it, because there's so many things to work on, and there's so many opportunities to kind of define the standard, which is really exciting. And so, if you're interested, this is a great place to kind of check out what's going on with WASI Observe. We talk about some of our user values, our technical values, our goals, all these kind of different things. But what I'd really love to do is kind of demo some WASI Observe stuff for you, which is super exciting. This is kind of like the first inaugural live demo of some WASI Observe work I've done. So over the past kind of month or so, I've been hacking on like a really prototype demo of what WASI Observe could look like within Spin. Shout out to Lan, and then another engineer at Fermion for tons of help on that prototype. But yeah, let's we'll see how this goes. This is kind of live, but I'd love to just do a little demo of how this is working. Okay, so if I just pull that up. There's I need to explain one more piece of context before we do the demo here, and this like one other piece of context is that there's kind of like two ways that WASI Observe is intended to be used. And so the first way is as like a tracing or observability provider, and the second way is as a sink. And to describe that as like simply as possible, WASI Observe acting in kind of the sync role is basically acknowledging that when you're like compiling your Spin app or your WebAssembly component, you're probably going to want to use the like standard open source OpenTelemetry libraries that exist that already do a lot of the work. So, for example, this is OpenTelemetry library, the OpenTelemetry library for Rust, and this does all the work of like creating a tracer and like adding attributes to your span and adding events and linking your span to other things and tracking the timing and all these different things. And it can produce this like concrete finished span. And then all that this wants WASI Observe to be in this case is a sink. It just wants it to like be a backend that it can push a finished span to, and then that WASI Observe backend pushes that off to the OpenTelemetry collector, and you have your spans. That's one use case. The kind of other use case is like WASI Observe wants to act as a provider. And acting as a provider means it's kind of filling more of this role that in an OpenTelemetry library might, meaning that like you're directly using WASI Observe to like create the span, and then you use WASI Observe to add an attribute to the span. And so this kind of more complex provider use case is like useful if you're writing like a really simple component where you don't want to pull in the whole OpenTelemetry library as a dependency, but you still want to be able to do some tracing. So we'll dive into the demo. I think that's pretty abstract and kind of hard to follow without seeing code or some demo. So let's just dive in here. Okay, so I probably should have had this building first, but we'll just do it live, which is fine. So if we go to my prototype locally, observe prototype, and then I want to check out this version of my prototype locally. So we'll go, whoops, didn't copy paste. Also, please excuse all my really weird Git aliases like Gitch and Gibber and Gist. It's, yeah, I've gotten too used to them to back out. Okay, so we'll build that. Then we will come across here And so we will come out of here. So this is in a different, okay, so we've got Spin. We're building Spin, the prototype of Spin locally that supports WASI Observe. And then we've got this new library I'm creating called OpenTelemetry WASI. I'm only doing work in Rust right now. Eventually this will be able to support Python, JavaScript, all the languages. But OpenTelemetry WASI is basically a corollary to like OpenTelemetry OTLP, where OpenTelemetry OTLP is like the backend for sending OpenTelemetry data to an OTLP host. So like the OTeL collector is the perfect example of that. OpenTelemetry WASI doesn't exist as a Rust library yet, other than locally on my machine, but is basically going to be acting as like the WebAssembly backend. How do you emit this data from within a WebAssembly application? Okay, so that's chugging away and compiling. We can go into my example app. So we've got this OpenTelemetry WASI library, which maybe I'll click into the code and show you around in a second. But we'll go into our example application here, and I will show this to everybody. Again, if text is too small, please let me know. I tried to zoom in so it's big enough, but throw a comment in there if anybody's struggling to see what's going on. Great. So, is this the one I want to show? Let me just remind myself for this demo. No, it is not. Okay. So, excuse me as I just get this back on the right one. Perfect. So, this is, an example spin application. It's a spin app. It's got a spin.toml. It's backed by like a normal Rust app. Kind of everything's normal like you would expect. You've got your HTTP component handler. This is what's called. But it's unique because we're doing observability stuff here. So first we're going to call configure Ollie. Ollie is just like the shorthand for observability. We're going to, basically just use this kind of tracer provider, which I've written in this OpenTelemetry WASI library, which is using this WASI Observe under the hood. And we're just going to set up this global trace provider. And then we're going to, in our main function, start a span using this kind of global tracer provider. And then we're going to do some KV work, which is just, open up a KV store, set a value, and make sure that's traced. So that should be a nested span under the parent root span here called guest span. And then since this is dropped at the end, this is automatically closed. So basically, you call this app, it puts something in a KV, and you should expect like guest span and do KV work nested under that root guest span. Spin is built now. So if I go in here and I go spin release, this can work. And I pass it an OTeL exporter OTLPA endpoint, and it doesn't need these KV variables. Great. So I run this application. Then I come over here and I curl it, just make a request against that application. If my demo works, which things often don't work live, we should expect to see a trace. Perfect. So this is the same get you would expect from the Spin application, this kind of host level tracing that's emitted. But in addition to that, you are seeing this guest span and the do KV work we talked about. And then notice how nested under do KV work is the spin key value stuff. And these are spans actually emitted by the host. And so it's this kind of like really cool sandwich where you get initial spans emitted by the host. And then you get the spans emitted by your guest, whatever kind of spans your application logic dictates. And then those might use functionality by spin. And so you're getting these kind of more spin dependencies traces. So it's this really cool way to be able to kind of arbitrarily trace whatever you want. Just for giggles, let's go in here and demo hello, just to prove that it is in fact working. So we'll just have to spin build the app, and then we'll just run the app again. And we should expect the span name to change. There we go. Hadn't loaded yet. Guest span demo hello. Cool. So we've demonstrated that is working. Now, I just want to show a little bit more detail of what like using WASI Observe actually looks like. And to clarify with my earlier kind of like contrast of the sync and provider use cases, this is an example of the provider use case where we're directly using um, this kind of like WASI Observe as a provider to produce the spans, add attributes, all these different kind of things. So here's like a alternative um, yeah. Whoops. So, okay. So here's an alternative spin app that more directly shows how we are using the WASI Observe as a provider. And so we're importing Spin SDK Observe, and then we're saying span enter. This is how you actually start the span, and then ignore these parts. This is how you close the span, and then return a response. And so, everything we are seeing in here, configure Ollie, is basically like a library wrapper around using it as a provider to make it a bit cleaner and simpler to use. Um, Again, I want to highlight, this is like super, super hacky early day stages where this is like one happy path works and I just got it barely working. But it sort of demonstrates how we can use it as a provider. And then in a second here, I'll switch to showing how we can use it as a sync. Okay, I got a question here. If you want to use a library in Spin apps, which kind of crates are allowed and does work for WASI platform? That's a really good question. So answering that like generally, what libraries are you allowed to use? Um, the short answer is like some, but not all, and I don't actually have a nice convenient answer for how you know which ones will work in advance. I think we might have like Spin Developer Hub. I think we might have on Fermion Developer lists of like well-supported libraries, but like as a general rule of thumb, um, things that are using threading in the background or like that are using networking that don't support WASI ways of networking, um, are not necessarily supported. And so you often kind of have to play this unfortunate game of like use the library and see if it works in the app or not. Um, Over time, that's going to get better as more and more WASI support makes its way into upstream libraries that you're going to depend on in your app. And it's also important to note that it's like very language specific. So, for example, in Rust, you might expect a lot better library support than maybe you might expect in like JavaScript or Python. Um, so I don't know. That's kind of the short answer to your question. Um, Let me know if that answered your question. And also, maybe hop in our Discord, which I'll try and find a banner for. Because I definitely know there's a lot better answers to that question than I'm able to provide. And there's people on our team who are able to kind of provide better answers to that question. I'm just trying to find a link to our Discord here. Hmm. Okay, well, I can't find a link to our Discord, but maybe at the end I'll find a banner and throw that up on there. Um, yeah. Okay. So that is the provider use case. Projecting 3 months down the road, 5 months, I don't want to commit to a timeline, but as WASI Observe kind of coalesces into a more firm standard, um, we can probably expect that the Spin SDK will kind of provide this tracing functionality for when you don't want to pull in the OpenTelemetry libraries, and it will make it easy to just like, you know, I need to I want to know how that long this single piece of functionality takes. So I'm going to emit one span here. And that kind of provider use case will be useful there. The other use case is the sync use case. And I'm just gonna, for the sake of time, get this building. So if I just get back to the latest, make and rebuild that. Okay. Well, that's going. So this is going to be a different how do I describe this? Sorry, this is even fresher. This I got this working a day ago. So we're really doing live demos here. Um, let's start with showing what the demo app of using this looks like. So it's a similar app. You're starting to span, you're doing some KV work, you're tracing the KV work, all these things. Um, what looks a little different is we're using um, actually, am I on the right branch here? This doesn't look right to me. Hold on. This isn't right. This needs to be on exporter. Okay. Hold on, folks. Bear with me. Let me undo my changes here. Let me check out my branch. There we go. Now let me build this. Okay. So here's our sample app. Again, we're doing similar things. We're doing KV work, all this stuff. What's different this time is configuring Ollie. Um, observability. Sorry, I like using the shorthand there. And so before we were using this kind of like custom provider and all these things, which I didn't really go into and isn't really important. But the important point is now what we're doing is we're just using a custom WASI exporter and then like ignoring that one line, everything else is like the exact same that you would use in a normal application. You're using the exact normal OpenTelemetry tracer provider, all the normal OpenTelemetry machinery that a Rust application would normally use, and you're just swapping in a WASI exporter so that you can export the um, traces out of your WebAssembly application. Normally you'd be doing something like it doesn't quite look like this, but it'd be like OTLP exporter in a normal app. Just directly do that. But instead, we're using WASI exporter here. And so this WASI exporter is like under the hood, sending completed spans off to WASI Observe, which is implemented in the Spin backend. And let's just do a demo of this because it's probably done compiling. Perfect. So if I run this, cool, that works. Okay, come here, don't need that. Perfect. So we can see a bunch of traces have come out. This is the GET request against the app, and we can see the guest span was emitted, and we can see, set and do KV worker emitted. Now, there's an important difference here that you might have noticed, which is, last time wasn't that nested under there? You had guest span as a child of these kind of like parent spans. And why is it just not being a child this time? Well, the answer to that question, in short, is I haven't implemented it yet. And so, as this demo improves, we can imagine in the future we'd be able to do something along the lines of like when we do the span, it'd be like start with context, and then there'd be some sort of like open telemetry WASI get parent context, which would get the context of the parent. In this case, this would be the parent, the execute WASM component. And then it would be able to like tie that all together into one trace. But that's not implemented yet. But it gives you this kind of idea of how we'd be able to support this sort of use case where you're using all the standard OpenTelemetry libraries. Okay, so I'm seeing some questions here. I'm going to start with Mohammed. It would be nice if WASI Observe would be config driven. I don't actually know what that means. So I'm going to go to the other question here. And Mohammed, I'd love if you could put some more info in chat about what it means to be config driven, because I'd love to chat about that. Okay, Otis says, it seems really interesting to write libraries that work in Spin. Totally agree. One of the things I'm like hoping I can get out of doing this live stream is exactly this, and like getting people interested in working on these things. And working on getting libraries that work in Spin is like an amazing place to get started in contributing to Spin. Again, I highly recommend getting into our Discord. Maybe I can just find a link through the developer channel somewhere. Engage on Discord. Perfect. This surely has a link. Okay, I don't. I'm doing all these things. Well, maybe this works. Yeah, I just think that's a fantastic place to get involved and documenting which libraries work. Adding new support for libraries, kind of like all those different things. So that's really awesome to hear. We're nearing the end, so I'm going to keep answering questions here. But we're pretty much at the end of the demos I want to do. Unless people come back, with more ideas of demos they want to see or questions they have, or questions about WASI Observe, I'm happy to talk about that in more detail. but yeah, we'll keep the questions rolling here for a few more minutes, and then go from there. Maybe while I wait for a response from Mohammed, I can search config driven. Understand what that means. Awesome. Otis. Cool, cool. Payment library for some payment gateway. Yeah, that would be handy. There's I know one of the things we're doing then in the spin cube space is like this kind of like event gateway adapter work, basically, so you can support triggers for just like arbitrary events in the cloud. I know this is kind of different what you're getting at, but it's this like similar concept of like these like adapters that let you, support all these different kind of this wide array of things, with one implementation. So cool. That's awesome that you remember and contributing. This isn't to Mohammed's question, but it'll be interesting to see how WASI Observe iterates and develops. I know right now we're really focused on tracing work, um, but over time, I think the plan is to support all the different signals of of OpenTelemetry, so tracing and metrics and all of that, and have support in a number of different runtimes. So Spin and WASM Cloud and all the different places. So it's an exciting space to check that out. For I guess I can plug this too for anybody who's interested. Um, where is it here? Yeah, I guess I'll just share this for anybody interested. The meeting's actually tomorrow morning, Mountain Time. So if you're interested, it's fairly easy to get involved. You just have to sign up for like the WebAssembly working group and then email Chris Dickinson, and you can get kind of plugged into that community. Awesome. Well, it seems like there's no more questions. So thanks everybody for hanging out today. I had an absolute blast kind of giving the whirlwind tour of all the different things we're doing in the world of observability for Spin, giving you a taste of the kind of the host level observability we're doing in Spin and the guest observability. It's an exciting time. Keep your eyes peeled. Way more functionality is going to be landing in 2.6 and 2.7. It's just going to keep coming. Uh, Keep filing those issues if you're looking for different kinds of support. All those different things. Let me get a GitHub link for my repo here for folks to check that out. And yeah, thanks for hanging. And again, we'd just love to hear feedback because we're at a point where we're supporting a lot of things in observability, but it's really up to the community now and the kind of things y'all are looking for. So awesome. Thanks for having me, everybody. That's all for the stream today.